Hello everyone, my name is Omar and welcome to my channel. In today's tutorial, we will be learning how to create a stylized omelette sizzle on a pan. We're going to be utilizing Houdini 20.5's MPM Solver, create quick and dirty procedural sizzling bubbles and stylized steam, and render our scene using Solaris. And then, we're finally going to use COPs and Houdini to ensure a stylized, almost an anime kind of look. This isn't going to be a step-by-step tutorial, but rather a walkthrough. But do not worry, I will be providing the project files for you to easily follow the tutorial. Let's get started. Okay, let's create our MPM simulation. I created an MPM container. I put the particle separation as 0.001, and I scaled it down so that we save on computing power when it comes to the simulation. And I positioned it roughly where the pan collision geometry is. Moving on, I found these 3D pan models from Sketchfab, and I chose this one in particular to use. I used a match size node to center it in the world space, and then I made it smaller so that it's closer to its real world size. And then I flattened out the pan so that it has that flattened out look. And then I used an MPM collider. This is going to be our main collision geometry. It creates a VDB out of the collision geometry. I set the voxel size to 0.001 and I scaled down the friction to 0.29. Okay, let's move on to sourcing our oil geometry. For that, I'm going to use the flattened out pan. I'm going to blast out the unnecessary surfaces. I'm going to have the bottom portion only. I'm going to use an attribute delete so that we get rid of all the unnecessary attributes. And then I'm going to use an MPM source. For this, the point separation is linked to the MPM container's particle separation. So it's directly referenced. And for all the other sources that we're going to create, we're going to reference it like that. For this, the point separation is 0.001. The material preset is set to water. The behavior is set to viscous. The density is 1000. These are all the default settings. Only the viscosity was put to a lower number, which is 0.001. And then I want to delete some portions so that it has that oily look. I added an attribute noise. You can visualize the noise if you want. Here's what I have, and I blasted out some portions. And then I use a transform node so that this oil sits directly above the pan so that it's not colliding or it's not going below the pan. It's a tiny touch in the y direction. And I grouped this and I called it oil. After that, I colored this for just visualizing purposes. I set up this noise out. And voila, we can move on to creating our egg whites. For sourcing it, I created a sphere. Made sure the sphere is almost like an oval. I scaled it down and positioned it right above the pan. I used the mountain node to add some noise. And then used an MPM source. This is similar to what we had in the oil. As you can see, the point separation is linked to the MPM container's point separation. The material preset for this one is set to honey, and the behavior is also set to viscous. The density is 10,000 for this one. The stiffness is 0.3. Volume preservation is set to 0.4, and viscosity is set to 0.005. I grouped this one as well, called it white. You can call it egg whites if you want. And then I colored this to white. Moving on to the egg yolk, I created a simple sphere. I colored it. And then I used a transform, which is directly referenced from the transform that has been applied to the egg white. I used a slight transform on its y-axis, moved it up. And then I used an MPM solver. Point separation, as you know, is referenced by the MPM container here. And then I set the material preset to honey and the behavior to viscous. Density is 10,000, stiffness is 0.1, volume preservation is 0.4, the viscosity is 0.3. For this one, for some reason, maybe I forgot what the reason was, but I added a plasticity of 0.001. Maybe because I wanted the shape to preserve more. After that, I code the yolk, and I colored it. And then I merged these. Since the sources here are set to emission type 1s, it's going to be emitting on the first frame. So what I want to do is, ideally, I'm going to have the second yolk appear after the first yolk gets dropped down, after 25 frames. I added a point velocity for this. Just added a slight curl noise with a scale of 0.45 and swirl size of 0.005. And I transformed it slightly to its right. And then I merged them together. So what we have for the egg simulation is the first yolk and egg white going off in the first frame. And then after 25 frames, you have the second egg white and egg yolk coming off. And then I added a general time shift just for timing purposes. I wanted to give it 10 more seconds before we could see the egg dropping down. And then I merged it with the oil source. The oil source gets emitted only on the first frame, so you only see it here. And then, yeah, you only see the egg yolk and egg whites come off after. As for the MPM solver itself, we're gonna need 3 inputs. We're gonna need the sources first, which I plugged into the first input, and then the collider in the second one, which is our pan, and the container. For this, that's why I created a null after the npm container. I just referenced it in the object merge here and I plugged it in. So let's see what we have. This is the general gist of it. You can play around with the values, maybe make the oil around the eggs jitter, but for our purposes, since this is a very stylized look, I think this is going to be enough. Let's touch upon what we have in the MPM solver. Yeah, I didn't touch anything here, only I lessened down the gravity here. And this is not an ideal touch up, but for our cases it works. So moving on, I'm gonna fast forward this section because I have already a cache saved out. I'm gonna show you the cache. So here's our cache. Both of our eggs are being cracked and dropped on top of the pan. We're gonna mesh these first. Let's mesh the oil. Since we created the groups in the top section, I'm just gonna use the blast node, use the delete non-selected, and then put the oil group name here. And then I'm gonna use a particle fluid surface, and I'm gonna get this. I colored it down again. And here's what I have. And I meshed it down again. It takes a while for it to settle on the pan for the first few frames. That's why I use the clamp to first on the time shift and put the start frame to 4. That's why you see this time shift here. For the yolk, I use I blasted out singled out the group of the yolks. I used the particle surface for this. Use the particle separation of 0.001, similar to what we have in the npm container. These are the yolks that you see on the simulation. I colored them and I meshed them. For the egg whites, I used a similar approach. I used a particle fluid surface. Maybe you went with a particle separation of 0.005. This is very dependent upon how you want it to look. You may want to set just to 1 and have it more smoother maybe, or thicker, depending on how your simulation is. All of these numbers are very arbitrary, as I mention all the time, and could be changed according to your preference. I colored it to not exactly 100% white, but slightly like a pinkish hue to it. And then I cached it. After the egg whites are cached, what we want to do is create an attribute for this so that we can play around with the transmission and the emission settings of the egg white itself. Because as you know, when the egg first gets dropped on top of the pan, what you see is a clear liquid kind of look, and then it gets that whitish look after it gets cooked. So what we want is a noise on this. Have this noise attribute, and then I have an attribute triangle whereby I create an attribute called emit, and then I use a fit range function here. I fit the age multiplied by the noise attribute that we created earlier, and then I remap its minimum and maximum values to 0.05 to 1. For this, you may ask, why do you go with 80? You can take a look at your geometry spreadsheet and see what is the maximum age number here. For my case, the maximum age amount was 80. That's why I set this maximum amount to 80. And then I clamped it down with a time shift to 120 so that it may have some jitter afterwards. I didn't want it to have that jitter, so I clamped it down. So the meshes are complete. Let's first create those small details that you would see on the pan. Very small bubbles that are sometimes visible on the heating oil. I have this oil geometry. I scattered some points on top of it, and then I used a copy to points with a sphere. Here's what I have. They're very hard to see. And then I used the mountain node so that they each get applied a noise with time. I made the pulse duration to 0.5 for this, and then made the element size a very small number like 0.015 and amplitude is 0.01. So this is what you get. Moving on to the sizzling bubbles, what I have here is an oil geometry, and I have the egg whites. What I want is I want to isolate the around edges of the oil that is almost touching the egg whites, and I want to emit bubbles, sizzling bubbles from them. So I added an attribute wrangle to the oil geometry. I called it sizzle is equals to 0, and then I added a similar one here, and I called it sizzle is equals to 1. And I transferred this attribute, as you can see. And then I made sure what I want is the outer portion. So I blasted out sizzle equals to 0 first, and then I blasted out sizzle equals to less than 0.9. So this is what I have now. After that, I added a scatter to this, and I randomized its P scale. And then I copied some spheres on top of these. So this is what I have. This is good enough, but for stylized look, but we're gonna add some more stuff to it. I'm gonna add a mountain like I did with the pan oil bubbles. And then I added a scatter to these. I used the attribute delete to get rid of anything that we don't need. And then added a point velocity of, because these ones are procedural and they don't have a, and they get changed every frame. I just wanted to add some subtle velocity to them. And then I added a particle fluid surface to merge them together, and this is what you get. Very simple sizzling bubbles, quick and dirty. And I cached it out. Here's what we have. After that, I would like to create a stylized steam. I'm not going to do a pyro simulation for this one because I feel like doing it procedurally may give you that very stylized, cartoony look. So for that, I have this object merge here, and it's referencing the oil geometry. I convert it into polygon. I time shift this so that it stays stationary, point count doesn't change. After the time shift, I use the scatter node. And the scatter node has this expression here. So this expression makes sure that every 4 frames, a point has been emitted. And then I set the global seed to time so that it changes the seed every frame and you don't get points emitted in the same location. I used an enumerate node and I changed the attribute to ID so that every point has an ID attribute. And then I plugged it to our popnet. For our popnet, it's a very easy setup. I basically have them traveling upwards with a pop force. I use the emission type of all points here. And then I use an attribute delete to get rid of anything that we don't need except the ID here. And then I use the trail node here so that they have a length. And then I use an add node. And if you go to the by group option of the add node and change the attribute name to ID, you're going to have these lines. This is connected to the enumerate node that we created. And then I resampled them, made sure each line has enough points for us to apply some kind of noise on top of them. Made sure the curve view attribute is being exported. And then I created a point VOP. In this point VOP, we have a bunch of ramps. Curve view attribute that we created with the resample node is gonna come in handy here. We're gonna plug that into our density ramp, p-scale ramp, and our noise ramp here. As for the density ramp, it's basically like a hill setting that you can find in the presets here. The p-scale is also set to a hill, but the amplitude is set to a lower number. We want to have the noise on the middle portion, but not on the tips of the lines. That's why the noise ramp is 0 on its edges. So this is 0 and this is 1. So that's why the ramp is only starting from a certain number. And I multiplied this with a global multiplier of the noise, and then I add this to the amplitude input of the AA noise. I set the signature to 3D input and 3D noise, and I add it to the current position of our lines. And then I plug the output to the position. And then what we want to do is we want to use a volume rasterize attribute. And this is gonna create a density from the density attribute that we created earlier. And here's what we have. It's like a wispy, cartoony look. You may achieve this with Pyro, but it would take long, so it's better to use procedural ways for this. Make sure the voxel size is set to a lower number and the particle scale is set to 0.008. I use the normalize by clamped coverage here as well. And we're done. I cached it out. Okay, here is what we have for the MPM simulation and meshing of the meshes and creating extra details. I'm going to be seeing you on the lighting section now. Let's get going. Okay, folks, this is the rendering section. This is going to be our final result. I'm going to go through the Solaris network now. I'm basically importing every aspect that we created in part 1. I have the pan import in this section. I'm importing the pan, slightly transforming it, and then adding a material X standard surface material to this. I went with a specular of 1, roughness of 0.5, and an index of refraction of 0.85. And then I added the oil. As for the material of the oil itself, a metalness of 0.2, roughness of 0.03, index refraction of 1.85, and a transmission of 0.86. These numbers are arbitrary and can be changed as well, so don't worry about having to find the exact numbers. Just try to see which one works best for you. And then I have imported the egg white. The material for this is similar, but for this one I have imported the emit attribute for this, and I plugged it to the emission input of the material surface. These are the numbers that you can see. Base is 0.27, roughness is 0.15, metalness is 0.65. Transmission settings are as follows. Made the roughness a negative value for this one. The index of refraction for specular is 3. Moving on to the egg yolk. This is what I have after the egg whites and the egg yolks. These are the values that, as you can see, not much different from the other ones. And then I imported the bubbles, the sizzling bubbles, and the secondary ones on the oil itself. The material for it is pretty simple as well. Metalness of 0.17, roughness is 0.04, index of refraction is 0.1, and transmission is 0.65. Emission is set to 0.315. I added the steam, created a volume material for this one. Density is 1 and smoke brightness is 7. And added a Karma physical sky. Here are the settings. Alternatively, you can create an indoor lighting setting for this one. And then here's the Karma render setting, and here's what we have. What you're seeing on the screen is the output of the COP network. So if I turn that off, here's what we have right now. I'm going to be showing you the COP network section on how I got that stylized cartoony look. Let me turn that on. Let's dive into the COP network. But before we dive in, before I forget, these are the limits of the Karma render settings. I also have some AOVs turned on, like direct diffuse and combined glossy reflection. These are going to be useful when you're doing the slab comp in the COP network. Let's dive into the COP network. So essentially what's going on here is we're getting our slab comp by using a slab comp import node here. We're plugging it into our block begin and making sure our AOVs are being transferred, like color, depth, combined glossy reflection, direct diffuse. After that, I'm going to take the direct diffuse of this and turn this into an RGB NTSC luminance. It's going to convert it into a grayscale for this. I'm going to remap it. And then I'm going to remap it some more at the bottom portion so that we have this cartoony look, two values separated together. And then we're going to max it out and join it together. After that, I'm going to use an edge detect contour for this on the direct diffuse. Going to get this outline of the egg yolk, and we're going to merge them together with a screen blend node. So this is a mono right now, and we want to turn it into a color. And this is the color ramp that I went with. I went with gray to blue to kind of whitish to yellow. And these can be changed as well. So don't worry about getting them right. So after the color section here, the ramp, we want to turn this into an RGBA. And for that, we're going to need an alpha. And for that, we're going to use an RGBA to mono. And then we're going to plug it in. And the settings here are the signature is RGBA and operation is maximum channel. And it's going to give you the outline of the render that you're getting. Once you plug it in, now we have an alpha channel. Now, what we want to do is we have this color thing here and we want it to multiply it with the existing slab comp color. So once we do that, this is the result that we're going to get. Some sort of a brighter color. And yes, you can do this in your compositing software of your choice. And it doesn't matter which one you do it from. It's just that Houdini's new comp system is very useful in doing these quick slab comps. So I would recommend you to learn and try to use this more often. I use the contrast node after, and then I ended it out. And this is the result that we're getting. For you to be able to render this to file, you first have to render the render that you're getting from Solaris first, and then you may plug it into the slab comp inputs here and then render it out again from COPs, in our case, like this. And here is what we have, folks. I hope you enjoyed this tutorial. If you liked it, please subscribe for future content. I'm going to be making more of these in the coming days. And I'll be providing the project file in the description. And have yourself a nice day.